Okay, so what are we doing today? Well, I'm hoping this will be a short video, but we're playing with ionizing radiation because that's safe. Well, not really, but the scale we're doing it at, it's not too bad. Alright, so if you've seen any of my other videos, you'll notice that I recently got the final amount of parts to make my Geiger counter work, which is great. And I've got 4 extra boards to play with. Now, I've given one to Tinkerman Mick and a full set of parts, and I also have a spare tube which I'm using on this second board. This is intended for another project, but for the time being I'm going to experiment with something that I've wanted to do for quite a number of years, somewhere in the area of 20 plus years. Now, when I was a child, I found in my father's collection this particle level meter. At the time, I didn't really understand what a particle level meter was for or what this came from. And in recent years, especially since I've started working for a military museum, I've come to understand that this was from a form of Geiger counter fitted to an aircraft. That's about all I know at the time being. But now that I have a real Geiger counter, I'm trying to figure out if I can make it actually drive this to a suitable degree. So, where are we at? Let's jump to the circuit and have a look at that. Okay, so this is a Mighty Ohm Geiger counter, and by all means I encourage you to go to mightyohm.com and order your own kit if you want. I went around this in a slightly dodgy fashion. I found that it had shared the designs with PCBWay, who manufactured the boards. So I had 5 of them produced for not very much money. I then went and sourced individually all the other components required for this board, and a few that I actually didn't need. Anyway, which was quite an arduous procedure, which has taken around about 3 months. In any case, this is running on 3 volts. Now, what I wanted to do was to have a meter react more than to 100 microsecond pulse, which is what is being fed out these pulse outputs. So where I'm at the moment, I've got one of the spare 2N3905 or 3904 transistors, just because I've got several hundred of them now, which you'll probably see from one of my other Geiger counter build videos. I've got that set up to be triggered from those 100 microsecond pulses, and then I have each pulse charging a capacitor. And the idea behind that is that I'll have a decay, so as the count increases, the voltage on that capacitor will be on average higher, which should mean when I feed that through to the particle level meter over here, the dial should go up and softly come back down again, instead of having little jerky motions. And that should give us an average count, which I think is somewhat similar to how these would have originally been driven. So let's get this all hooked up and see what we can do. Alright, so I've got it all hooked up at the moment, and I've got a stack of stubs of thoriated tungsten electrodes. I'm going to see if I can make this count raise up at all. I might need to put some more capacitance or a little bit less resistance on there, but the behaviour is happening how I would expect it to. Gotta wait till the voltage gets up in that capacitor. I don't really have a source enough to make this tube really go mental, but yeah, we would expect the value to be a little bit higher, so it needs a bit of adjustment, but it is behaving the way I would hope it should, with my hand in the way, of course. So a bit more refinement and we'll get this happening. Okay, so a month or maybe 2 has passed. I've lost track of this project. But here's where I'm up to now. I've resumed this after doing a bit of upgrade work around here. So I now have the behavior I wanted with this. If we can see on camera here. Here's my particle level meter. And you can see as we get particles, it will jump up and average the count using a big fat capacitor. As it turns out, I needed a 2200 mic. So let's just grab some of these tungsten electrode tips here and put them right near this bit. And we should see here our level should start averaging higher. And the more frequent the count, the higher the average, which is what we would expect. If I take them away, we'll see them slowly drop down, which is what we would expect. Finally got the values worked out for this particle level meter. So let's go over how I've done this. Let's have a look at our horrible mess here. So
instead of tapping off the pulse output and all the other junk I could do, I've just jumped straight off the back of this LED here and hooked an opto coupler in the way. The opto coupler is then triggering this relay here. And this relay is basically pulsing into this capacitor here. So every time it's on, it's connecting to that through a 100 ohm resistor, or no, it's through a 390 ohm resistor. That's the one that ended up working the best. So it's just cutting across that. The other half is of course onto ground. And then we have here, we've got two 10k resistors in parallel across the meter here, just to keep the current limited. And I found 5k was pretty close to full scale on this. And if this thing's full scale and I've got something radioactive in front of it, I'm going to be wanting to worry about what that is. Now, when I'll put this onto a prototype board very shortly, and then when we do, we'll mount it all in here. I'm not quite sure how I'm going to go about the dual voltage supply here. I'm probably going to use an LM7805 to run the 5V side of all of this, and while I'm at it, with the 3V side I do have some regulators. They won't take 12 volts directly in, they'll only take up to about 6. So we might feed off the tail end of this 7805 into a 3V regulator to run this. But I do like the idea of having everything isolated, so I might leave just the batteries in it. But we'll see. If I'm going to screw a lid back on, I don't really want to have batteries in there. But anyway, we'll have a think about this and we'll put the prototype together. Alright, my desk's messy, so I'm a bit tight for space here, but let's see how we go. So this is our 5V DC supply. Down here we have our Geiger counter with its built-in 3V supply. That's the 3V supply is not listed at the moment. So we have our 2200 mic capacitor, we have our meter, our opto coupler, and our relay board. So, starting from the Geiger counter here, we're branching off or in parallel with the current LED, driving the input of the opto, and there is a 390 ohm resistor in line with that, or 330 I believe. Anyway, that limits the current to the opto. Now the output of the opto is going up here to pull ground, to pull this pin down to ground. The problem I've got is the pulse output, and a lot of these things all like to output a high pulse. Most of these relay boards are expecting a low pulse. I reckon that's a stupid idea. Anyway, basically the opto grounds out that pin there, the input pin. And obviously the relay board has both ground and VCC connected to 5V respectively. Now, across the normally open contact of the relay, I have a 390 ohm resistor. It just happens to be what I had laying around, and that limits the amount of current that is being switched through the relay using the common back to this 220 or 2200 microfarad capacitor. So that just slows the charge rate a little bit. The other side of the capacitor is through the meter. Now the meter is current limited using two parallel 10k ohm resistors. I'd use a 5k if I had one, but that's what I've got. So that just means that if this is at 5 volts, the amount of current through this meter will only pull it to about 95% or so. Not quite full scale. So it can't go full scale with these in line. And this capacitor here will just generally buffer the pulses that are coming in. The relay means that we can regulate the current using this resistor here. So I could put a variable resistor here and adjust the charge rate and calibrate it using that. Same as this, I could use two knobs for calibration. But for now, being as it's a 1 to 10 scale, it's not in microsieverts or anything I can really figure out. That will do. This will make for a good effect, and my particle level meter will again be measuring radiation. So here's the circuit if you're after it. Alright, so this is a couple of hours later, and I've been a bit busy. I'm having a bit of an off day today. We'll discuss that later. I've been using the highlighter. In case you're from a different region, that's what a highlighter is, to highlight the tracks as I built them. I've converted everything to a small prototype board, and I've used a small 5V regulator board because I ran out of LM7805s. Otherwise that would be a bit more simple. And I used, where are we, on my messy desk, some 30 gauge wire, I think that is, to fill in all the tracks. Now let's hook up 12 volts to this regulator, and that should bring it down to 5. I'm still running the Geiger counter on AA's. I think I'm going to continue to do that. But you'll see with each pulse count, the needle jumps up a little bit, and as the capacitor drops, it keeps the average for around about a minute. So I'm looking for about counts per minute anyway. So what we'll do in a moment is I'll grab some electrodes. Sorry, I rolled the wrong dice this morning for MS, and I'm having a bit of a hard time with it. Let's see with my left hand here if I've got the dexterity enough. I'll get a couple of these thoriated tungsten electrode tips, and I'll drop them on the floor. We'll lay a couple over the tube here, and we'll see here that the count should start to come up. And that's the behavior I wanted. And I've got a nice classic sort of ticking sound that's a bit ominous, and I might even extend this LED off the board to use that as a new indicator LED, because the one on the board here now no longer works. So I've removed that and put a pin header in there, and I've hidden my 390 ohm resistor underneath this board. I won't show you just yet, it's not pinned down, but the circuit is working. So I think I'm going to start designing the second control bay here and make room for this. Alright, well, I'm sorry I didn't capture the build assembly here. Yeah, we got the laser cutting montage, and then we've jumped to this with it nearly already assembled. Well, my senior technician, aka my father, dropped around, and we sort of did a bit of a collective project and worked on this together. And I kind of valued the time more than I valued recording it, so that's where we're at. Anyway, we're at smoke test time, and I've got my 12-volt wire hooked up here, and spin around to the completed project. What you probably didn't see on the design in the AutoCAD was this little shelf I assembled in here. I designed that to keep everything in one module, with little feet here so that it sits on the bottom nicely. In any case, I've got 12 volts going around here to a double pole switch, and I've got 3 volts being switched on the other side of that switch as well. So everything looks fairly good at the moment, nothing smoked up, and we've got 14 volts into it at the moment. My little regulator chip that you can probably see on the bottom here, that regulator board blew up. I'm not sure why, but I put my finger on it and it let its magic smoke out. So, don't know what happened there. Anyway, we have an LM7806, which is a 6 volt regulator. I had dozens of them and I didn't have any 7805s. The relay is now housed up here. The prototype board is hot glued in here, and I've got the batteries in here with blue tack just to facilitate replacing them. So let's see if this works. No magic smoke yet, but no beeps either. It's not very radioactive in here, so... Oh, we got a beep. Okay. Must have been the boot up. My father tells me he has another one of these identical as well. He's had for about just the same amount of time. So let's grab myself a test source and see what happens here. Oh. So now I have a little shelf here that is designed to slot into here so that we can put a sample down there and hold it near the tube. I'm not sure how well it'll work for this, but we'll put this right here. Now I found that a 2200 mic capacitor across this with the resistance I've got takes approximately a minute. So this does give me some sort of counts per minute reading, but on a scale of 1 to 10 it's a bit hard to tell. I'll have to do it against a real Geiger counter, or rather I might have to check the serial output of this and determine what the microsieverts are relative to this meter. It does have a serial console. I might be able to feed that across to the other side of my unit here, where on my little OLED I have an Arduino behind that. I might be able to get it to read the serial data. But this looks like it's working well. Let's put this right up next to the tube from the other side and see what happens. Not much apparently. I want to try and get it past 4. Although the motivation to do that's not high. So anyway, so far it's working well. We've got a few other things to finish off. I've got to put the light in here and a few other things. But so far I'm happy with that result. So we'll turn that off, and yeah, I'm going to test mount this so that you can see it in situ. Remove all the junk out of here, and this spare cable that I'll use later that can tuck in the back for now. We've got a cable attached to this that I need to roll up out of the way, so that can tuck in on the top. Let's insert everything in on the tray. This looks like it's actually going to go in very nicely. Alright, so that is going to sit in there quite well, and we can remove that. Now I have my little dual voltmeter which is going to go into that slot. However, I cut the tolerances a little bit fine and didn't account for these two little ridges, so I'll sand them out shortly and that'll go in as well. I'm going to run the wires over, and then after that I'm going to be otherwise committed for the rest of the evening, as it is the 31st of October here, and I have an American wife, so she's got some arrangement about Halloween or something along those lines. So apparently I'm driving. So yeah, I don't know, it looks like that meter's not quite straight, but I'll measure that up after the fact when everything's in and I can't do anything about it. So yeah, two things to do. I've got to get this meter in and that light in, and the headphone stuff we'll figure out later. I'll wire that up when I've got more time. I've got about 40 minutes to get this done before I have to be somewhere else, and it's hot and uncomfortable and I don't want to be outside today, so I'm going to turn the air conditioning on max and try and soak up as much cold air as I can. Alright, so sorry about the background noise. I'm trying to cool down here. But I've got this temporarily fitted, and for the time being it's going to have to stay this way. I've got other stuff to do. But I just wanted to demonstrate that the detection light will work. We put something here. Or at least it did until I put it in here. It requires 12 volts through the relay. Anyway, the detection light is wired up and works. The 12 volts not connected at the moment. And I'm going to have to wait till later to demonstrate everything else. So we'll be back. Probably hours or days will pass for me, but it'll be in the click of a fingers for you guys. So see you back in a second. Alright, it has begun. I'm wiring everything up and transferring the audio over. I'm not wiring anything up to these four today. I'm going to do that another day, but I've got audio and headphones working. I've got all the Geiger counter stuff happening. I've got my negative ground rail and my negative ground rail as a positive up the back there. My Arduino hiding in loose. This is all going to need some cable management in the very near future, but for the moment I need to get it working, and then from there we'll be able to see an end product. So I'll have these screwed up in here fairly soon, and we'll do a bit of a demonstration. But yeah, we'll be very, very close to having mostly functional here. Alright, so here we are with everything screwed in. I have the panel you will have seen in the last video, and I have the new panel here. We've got a few things happening. Firstly, we've got the Geiger counter working properly in here, and you can probably hear when I put my sample up close to it, it's going to start going off and the radiation level is going to rise. So that works. We can take that away. And I've also got the audio bypass working. None of these are connected to it at the moment. We'll turn our Geiger counter off, and yeah, I do have the audio bypass working at the moment, and you can probably hear from my headphones here. So that works pretty well at the moment. So yeah, and I can disconnect my headphones, and I can bypass it back to the main audio, and all of that all works very nicely. I haven't used the switching in the headphone socket because that's notoriously problematic. They're always an issue, but at least I can have headphones right down here now instead of way up in the middle of the rest of my kit. So it does make privacy a little bit easier. But anyway, that's pretty much it for the time being for this. I think once I work everything out, these switches will become another video. But for the time being, this particle level meter is actually doing its job, and apparently now there's another one in the mix as well. So yeah, it's actually doing what it was originally intended to do after 28 years of doing stuff it shouldn't have done. So yeah, we're back, and it's working well. So I'll see you all in the next video, and I hope this was an interesting one.